Welcome to This Explainer. Today, we're taking a look under the hood of the electric utilities and power generators industry. It is a completely fascinating space, and we're going to figure out exactly what it takes to keep modern society functioning day in and day out. Because let's be honest, without them, everything literally grinds to a halt.
Think about it for just a second. You walk into a room, you flip a light switch, and the lights come on. But what are you actually paying for? Because you're not just buying electricity, right? You are buying into an invisible, sprawling web of physical risks, environmental costs, and some incredibly massive, capital-intensive infrastructure.
To truly wrap our heads around this, we're going to dissect the industry systematically. Here's our agenda. First, 1. Powering the modern world. Then 2. The climate and air toll. 3. Water and waste risks. 4. Energy affordability and people. And finally, 5. Grid resiliency and safety.
All right, let's dive right in with Section 1, Powering the Modern World. Subtitle, The Core Business Model.
We really want to do a deep dive into the electric utilities and power generators industry to understand its core activities. Basically, the industry breaks down into 3 distinct, monumental tasks. First up, you have generation. That's creating the power from sources like coal, natural gas, nuclear, wind, or solar. Second, you have the massive physical undertaking of building, owning, and operating the transmission and distribution lines. To put that into perspective, the U.S. alone has enough power lines to wrap around the Earth several times over. That's the grid. And finally, you have the retail aspect of actually selling that electricity to end users like you and me. Now, how these companies operate actually depends entirely on where they are. In regulated markets, you typically see vertically integrated monopolies. They own the whole shebang. Everything from the power plant all the way down to the meter on your house. But in exchange for that monopoly, they face incredibly strict regulatory oversight on what they can charge. On the flip side, deregulated markets split this all up. You have independent power producers generating electricity to sell in a competitive wholesale market, which is completely separate from the company that distributes it to your home. So, how do we measure the health and the risks of these massively complex entities? We use highly technical sustainability accounting standards, specifically the SASB standards. Think of these metrics as the vital signs of the grid. They track the massive environmental and social risks that utilities absolutely have to manage to maintain their license to operate every single day. Moving to our first set of vital signs, here is Section 2, the climate and air toll. Subtitle, Tracking the Emissions. The absolute crucial point here is the sheer magnitude. Electricity generation is the single largest source of greenhouse gas emissions in the entire world. We're talking primarily about massive volumes of carbon dioxide, methane, and nitrous oxide, which are mostly the byproducts of fossil fuel combustion. As global regulations rapidly tighten, utilities are in this relentless race to mitigate these emissions. If they don't, they're looking at crippling financial penalties and massive operational costs. And it's not just greenhouse gases. Utilities also have to track highly hazardous localized air pollutants. We're talking nitrogen oxides, sulfur oxides, particulate matter, and heavy metals like lead and mercury. What regulators and standards really zero in on is what percentage of these toxic emissions are happening in or near densely populated urban centers. Because when they happen near urban areas, the localized health risks and the subsequent legal liabilities for those utilities just absolutely skyrocket. Next up is Section 3, Water and Waste Risks. Subtitle, Constraints and Byproducts. So thermoelectric power plants, like coal, nuclear, and natural gas, require an enormous amount of water just for cooling. And this presents a huge operational risk. I mean, what happens when the water supply just dries up? If a utility is operating in a region with high or extremely high baseline water stress, they face the very real threat of their plants becoming stranded assets. That basically means they can't operate at full capacity or maybe even at all, simply because there isn't enough water to cool them down safely. And then, of course, there's the waste. Coal combustion products, or CCPs, include things like fly ash and bottom ash. This is literally one of the largest industrial waste streams globally, and it contains some really dangerous heavy metal contaminants. If this ash leaches into the groundwater, the litigation and cleanup costs can be astronomical. The silver lining here, though, is that utilities are increasingly tracking the percentage of CCPs they recycle, because when it's managed safely, it can actually be repurposed into beneficial materials, like concrete. That brings us to Section 4, Energy Affordability and People. Subtitle, The Human Element. Let's talk about the workforce for a second. These employees are out there facing extreme hazards every single day, working for long periods at great heights, operating heavy machinery, and navigating severe electrocution risks. So utilities meticulously track safety using metrics like the total recordable incident rate and the fatality rate. But they also crucially track the near-miss frequency rate. This looks specifically at the accidents that almost happened, which is a game changer because it allows companies to identify and fix safety gaps before a tragedy actually occurs.
Now, that human element extends far beyond workers to the customers. Utilities have a mandate to provide affordable power, but that affordability is heavily influenced by factors entirely outside of their direct control. A utility's pricing power is really at the mercy of local geography, severe climate and weather patterns, shifting public policy, and, perhaps most importantly, the underlying economic conditions and poverty rates of the specific communities they're serving.
Which brings us to a much more sobering vital sign: residential disconnections for non-payment. This is a critical metric for energy affordability, measuring exactly how many households have their access intentionally terminated and how quickly they manage to get reconnected tells a profound story about a utility's relationship with its community and how effective its bill assistance programs truly are. So we hit the ultimate tension in the industry. How can power companies possibly keep customer bills affordable, especially for the most vulnerable residents, while simultaneously raising the billions of dollars in capital required to upgrade infrastructure, build smart grids, and transition away from fossil fuels? It is an incredibly delicate balancing act, one they have to manage right alongside state regulators. Finally, let's assess Section 5, Grid Resiliency and Safety. Subtitle, Surviving the Extremes. The grid is constantly modernizing, right? Utilities are deploying these smart grid technologies, which offer some incredible benefits. They optimize demand response efficiency, they allow for way better integration of renewable energy, and they improve resilience to natural disasters. But it's a bit of a double-edged sword. Every single smart meter and digital node creates a brand new entryway for hackers, which significantly increases the infrastructure's vulnerability to severe cybersecurity threats.
When the grid does fail, whether that's from extreme weather or cyber attacks, utilities measure the impact using some very specific indices. The first one is SID, or the System Average Interruption Duration Index. Put simply, this measures time. It tells us in minutes the total duration of power outages the average customer experienced during a given reporting period.
And we can't talk about SID without its companion metric, SI-FI, the System Average Interruption Frequency Index. So while SID measures the length of the blackout, SI-FI measures how often they happen. Tracking these metrics, especially during designated major event days like severe storms or hurricanes, is really how utilities and regulators objectively judge the true resiliency of the local grid. We also have to touch briefly on nuclear safety. While incredibly rare, a nuclear incident presents a catastrophic tail risk. It's a low-probability event, for sure, but with massive, devastating consequences. Because of this, operators are required to undergo rigorous, independent safety reviews and maintain a profound culture of safety. It is way beyond just compliance. It's about emergency preparedness and actively identifying potential event sequences before they ever have a chance to materialize. So, pulling all of this together, what we are really looking at is an industry defined by a complex, high-stakes balancing act. Every single day, electric utilities have to juggle the protection of human life, safeguarding the environment, massive capital investments, and the critical social necessity of providing reliable, accessible, and sustainable power to absolutely everyone. I want to leave you with this final thought. The next time you flip that switch, think about the vast machinery operating behind your walls. As extreme weather events increase and our reliance on digital infrastructure deepens, is your local utility truly prepared, both financially and structurally, to keep the lights on? Thank you so much for checking out this explainer, and we will catch you in the next one.